Hello, good morning, everyone. My name is Kevin. I'm the training coordinator with the Association of State Floodplain Managers, and I'd like to welcome you to our presentation today. We are going to be talking about the agentic flow for flood modeling and forecasting. Very excited to have a two-part webinar series, first being right now here today, the next one being on Thursday. So before we get into the topic, it's a really good one, but before we get into it, some admin announcements. If you've joined us for a webinar before, this may be familiar to you, but if not, we'll kind of go through a couple quick things and then we'll get into the topic at hand. So first things first, I just want to let everyone know we're recording this event. So if we're going too fast, or maybe you missed something, or just want to reference this later for any reason, you'll be able to do that. So just want to let everyone know, don't worry if you missed something, you'll be able to reference this again later. A couple other things. We want to take audience engagement. So if you have questions, if you have comments about anything you see today, there's a Q&A feature here within the Zoom software, so please try to use that for questions. There's also a chat box. A lot of people use that for questions too. We'll try to keep track of the questions that we get there, but Q&A, that feature within the Zoom interface here is a better way that we can keep track of the questions. So if you have those and you want to lodge that, get it into the Q&A box. Couple other things. This is eligible for credits today. So if you hang with us for the entire event and engage throughout, you'll be getting credit. And I'll be uploading that to your record automatically. And I'll be sending you a certificate of attendance. Okay, that's nice, but that takes about a week, or maybe closer to two in the case of this being a two-part webinar series. Probably send one email with both certificates. So that'll take us a couple of weeks to turn that around. Please be patient, but this is eligible for credits, and the certificate will be coming to you from me, so keep an eye on your inbox there. Last thing, just want to prime everyone to get ready. We'll be engaging the audience with a quick poll. I believe that's coming a little bit earlier on in the presentation. So just want to let you know we'll be asking you to click through to a link and getting some information from you that way. So thanks again, everyone, for joining us and bearing with me there. I'll turn it over to Tyson with the AI subcommittee for a little more information about our topic, our speakers, and a little bit of the committee's work.
Thank you, Kevin, and welcome out, everybody. I hope you all had a great 4th of July holiday. I know I did. I took a trip up to DC and saw probably one of the most spectacular fireworks show I've ever seen. So I am Tyson James. I am the lead of AI implementations and commercializations for the AI Committee of ASFPM. And I plan to host several of these webinars, and as Kevin mentioned, the two-part series. So part one is what we are in right now. It's going to be about a 30 to 45-minute presentation, and then we're going to open up most of the remaining time for questions. So if you have any questions during any stage of this, please add them to the Q&A chat, and then we'll circle back at the end to address those. At the very end of this, we're going to leave a couple minutes for Yanan, who's the chair of the AI committee, to kind of give some updates on the committee itself. And then most importantly, this first part is setting the stage for the second webinar. And so part two, which will be Thursday this week, is going to be about a 55-minute exploration lab. So what this is you're given access to AI, to tools, to the guides, to reference data, and you're able to experiment for yourself. So my aim of doing this two-part series, and especially the second one, is to basically build your confidence and your knowledge of AI. At the very end, I'm going to have you guys take a survey. And so let me go ahead and share kind of what those survey questions are, so you can get in your mind what we're looking for and how you're going to answer those questions. So let me just share my screen right here. All right, and then, so this is what the survey is going to look like. It's very short. There's 5 questions. The first one is going to be very theoretical. Could you actually deploy what you have learned from the 2 webinars? Basically, how convenient is it? Second one is, would you actually want to adopt and implement this AI? The third is going to be, is there an actual use? Is there an authentic use case for this that makes sense to be using AI? The third And this one's a bit tricky because I know we're only covering 2 hours of learning, but how competent do you feel about the AI and do you understand it? And then lastly, it's going to come down to is implementing this AI, is it going to do what's right for everybody? And so those are the questions that I'm aiming for at the moment. So please answer those at the end of this. And then if you have any feedback, if you think we need to be talking about something that I haven't brought up or speakers haven't brought up or other topics, there's a line for you to do those. Now, realistically, we can only scratch the surface in these next 2 hours, the next two webinars of what we can cover. And I don't want it to end there. So I'm hoping that the fun actually continues here. And I wanted to give you guys a platform to continue those discussions. So if you want to keep learning about what's presented today, that is what I'm trying to do here. So ASFPM has this platform called Flood Zone. It's open to all ASFPM members. So I'll drop this in the chat here in a few minutes, but when we just kind of go over it, so there's a home page, and if you go over to this groups page, you'll see an AI committee or an ASFPM AI collaborative group here, and that is this group right here. And then in the discussions, we'll have each webinar. So, for example, here's the one this week, and you can click in here and add posts. Now, there's three things that I'd love to see here. The first is to see ongoing conversations. I'd love to see next week or even in a year for you guys to continue adding discussions in here. The second would be collaborating. It would be great to see, hey, I saw this feature on this tool, it wasn't addressed in these webinars. Does anyone know what it does? And, along our presenter on the call might be here to help you, but I would really love to see even just within the hundreds of people that are attending this call to help one another out. The third thing that would be great is to see success stories. And I'll present the speaker in a little bit, but it would be awesome to see, hey, we're a small town in Nebraska. We wear, mini hats and no one really has time to do floodplain management. But with these tools, we were able, to save 10 homes out of the floodplain or something that would show, success would be great for not only our committee, but the presenter and just kind of build momentum here. And then within this, there's also going to be the class materials, and hopefully I'll put a link to the recording. So if you want to come back, you can rewatch this, or if you missed it, you'll have a place to come and visit it. Additionally, we have a LinkedIn group. So if you go to LinkedIn and search ASFPM AI Collaborative, you can click this group, which will have similar information, and you can discuss today's call or just AI in general. And then with that out of the way, I'm going to go ahead and introduce our speaker here. So the presenter we have is Alongo Tavar. He is the founder and CEO of NEAR. And that company is very exciting. They've been on the forefront of AI predictive analytics even before ChatGPT was released. They're ahead of the game for sure. And he's on a mission to make predictive asset management and infrastructure or intelligence and tools accessible for every community on the planet. And that's not just some slogan. I'd highly recommend following his LinkedIn, and you would see that just this week, he delivered an ambitious effort known as the India Flood Atlas. It's a free flood mapping platform that helps 1.4 billion people. And something that I admire even more is that it's just the start of him fulfilling a promise to give back to his homeland and his people. So he has a very deep mission, and it goes beyond that. Even today, or I should say this week on Thursday, our presenter Alongo, he's donated, it's going to probably be thousands of dollars worth of AI credits to make what we're going to be doing on Thursday possible for all of us to participate and grow and learn how to use AI better. So there's a clear theme here that he clearly empowers people with technology to help them be better informed and make better decisions. And so today, I'm grateful to have him, and Thursday as well. And he will share his perspective on where infrastructure, floodplain management, and artificial intelligence are headed and what it means for all of us. So Long, I'll turn the floor over to you.
Well, thank you so much for that awesome intro. I should probably loop you in every time I'm getting introduced. So thank you so much to ASFPM, first of all, for this great opportunity. Let me share my screen and we can get started. Maybe swap the view. So we're good with the slides, Tyson? Everything looks good?
Yes, I can see it.
Okay, awesome. So few months back, I think Tyson reached out to me, hey, I really wanted to bring you in. We started this new committee. We wanted to be the first initial speaker. So I was very excited, and we've been talking for the last 6 months, and AI has changed significantly in the last 6 months. Um, so I was very excited about the new group. I also know, some of the founding members like Jan and, some other folks, and be able to connect after such a long time. And there's so much exciting things happening in AI space. So uh, every water resource engineers, feels empowered. So I feel that we have this renowned energy, so we can use a lot of this tool. So I'm very excited for this presentation. So thank you so much to ASFPM. So mainly I want to talk about the agentic workflow, where we can leverage agents for flood modeling and forecasting. And that's very practical application, and we can, move really fast in terms of providing deliverable to our clients, or even providing value to citizens and normal people that they rely on, like flood information. So I wanted to kind of talk around the agents and how it's very powerful to leverage this tool. So that's kind of my talk, and feel free to put your questions or anything on the chat, and I will be checking every few minutes. So again, my background is in civil engineering. So I started near around 2020 without knowing much about being an entrepreneur, and that was the time that AI was, getting popular around that time. And so main mission was to bring like affordable tools, because my experience taught me that there are a lot of challenges, even big utilities or small utilities, small communities, mid-sized communities, they all have the same challenges in terms of providing that decision support system. So that was the mission I started. We just like in any startup, we went through some issues and problems. So last couple of years, we had a reset button, and we were working on this new platform called Near, and so we able to bring all these agentic tools for a water resource engineering community, and also providing value to the clients in terms of uh, their decision support system, like asset management or modeling, hydraulic modeling, or leveraging the machine learning to build models, whether the flood forecasting and other areas of use cases. So I have probably like more than 20 years of experience at this point, and worked on a variety of tools like hydraulic modeling, watershed master plan, asset management, and most recently, the last 5 years of my career is mostly machine learning and AI side of applications. So that's about me. And I grew up in India. Just to give you a little bit of background, in a small community. I came to United States in 2002. Um, and um, and I worked in a big consulting, business for 15 years before I jumped into this being an entrepreneur. So that's 30 seconds about my journey from India to United States. We're grateful for the opportunities the US provided me, and education and mentorship and all those things. So I have a quick poll. I'm gonna put it in the chat. Give me 1 second, and it's only 2 questions. And if you guys can click the link and fill it out, and I will give like a probably 60 seconds. And this will kind of gives us the general audience profile, how often we use AI in our day-to-day activities. And at this point, I think everybody's using some kind of a agentic AI or some even AI tools. So I wanted to make sure that we get the pulse of the audience. And so And let me know if you have any issues clicking through that survey or any problems with that. It seems like some people have getting blocked by the firewall. Sorry about that. So if you just click that link, hopefully that should uh, uh, so you should see a link like this called like a straw poll, something like this, and then you can click through the questions. Okay, we got the person. Okay, I do see some submissions on my side, so we'll give another 30 seconds. Oh, okay, we got a lot of submissions, so um, almost 39 at this point. Okay, so based on the results, there's a lot of people used more than 50% people they used AI, which is really good. There's a lot of entries they use on a day-to-day basis, which is awesome. This is great to see. And I will summarize this results and put it on the flat zone so you guys can know the results, what percentage is where this is keep coming in. So if you don't have it, we'll send out through Tyson through email, or maybe when he's send out a survey, or we can also put it on a flood zone if you haven't filled it out yet. It's not a big deal. I just wanted to get a pulse of the audience to see. Thank you for so much for filling this out. We got like more than 200 responses. Thank you so much. Yeah, this is great. So the high level statistics is more than 50% of the people they used AI, somewhat AI. They also using it for every day as some kind of a tool like a ChatGPT or Claude or Copilot or Gemini. Very few responses that I have never used AI for work, and very few responses that says that the organization doesn't let them use an AI. So, okay, back to the presentation. All right. So one of the better thing happened in the last couple of years, especially when the open cloud came in to implementing the agent. I felt that that's going to change the way that we do things, not only in water resources, but it's impacted significantly in other industries as well. And that's the agentic era that I believe. The next era of like a modeling, especially, we spend a ton of time on, hydraulic modeling, whether we are setting up the model or simulating the model on our desktop, or maybe we are doing the QA/QC of the models. And that's going to be, we felt that that's going to change the way we do things. And we also believe, personally, that the next era is in better models. It's the system that translate information into timely informed decision. So we wanted to make sure that the decision support system, whether you're in a leadership utility director position or a public, they are relying on this information, how we can kind of boil down this information to help the clients to make the decision. That's what I believe the modeling is going to get better, because a lot of times as a water resource engineers, my experience is we develop this awesome models and it sits in a computer. It doesn't get used, and that's been changed in the last 5 years. But the percentage it changed is also very small. But I think with the agent coming into the picture, we feel it's gonna change the way we do things significantly in the coming months or years. Um, I wanted to kind of give appreciation for like a short history of water modeling. I know we all are very expert in, water hydraulic modelers, in the space, flood modeling. So the hydraulic modeling has evolved over time. All as early as, early 1960s, the EPANet, EPA-SWIM, HEC products, HEC products. And the second wave was the spatial .gis, ArcView 3.3. I don't know if anybody used this ArcView 3.3. I used when I started my own career, early 2000. That was, kind of very, very, very useful, kind of setting up spatially the basin maps, the subcatchments and all those things. And once in a while you get this HEC 1 and HEC 2 from the client. They are not ready to migrate to the HEC HMS and HEC RES. There are still clients there using HEC 1, HEC 2. Trust me, I know those clients, because they don't want to change the FEMA floodplain. So, but I think the spatial, that iteration is really great. And then the third iteration is mostly data, a lot of sensor, a lot of, satellite information, cloud compute that kind of liberated some of the desktop-based modeling. Only like a big companies are still kind of leveraging the cloud computing on HEC-RAS 2D modeling. I think the new iteration is most about intelligence. I believe it's about machine learning agents, large language models, and that can help us make us very powerful. And before, this is you do stuff like every day, maybe 1x. Now you can probably do 5x or 10x with these tools. I think ever since ChatGPT got released, and also the agentic, workflow, I think that's going to change the way that we are doing things. It's already did in a way. So, and the next one is why water remains reactive. In my opinion, is like one of the things that a lot of there's a structural constraints in like your fragmented data is there. Like, there's different providers, EPA and FEMA and Army Corps of Engineers. They don't work together. They're spitting out their own software, and there's a lot of different types of sensors out there. Um, and um, and also static models. We develop models, planning level models. That model never gets used other than planning in a real-time basis. And there's also very subjective, interpretation. And also the limited bandwidth, not only the computing, but also a human engineering perspective. We do have a limited bandwidth, only, we can lift, certain, so much work, and how we can kind of, increase our bandwidth to kind of help, several clients at the same time. And there are some operational, consequences on this. This is also kind of slightly changing in the last couple of years. So, a lot of tier 1 communities are more tech savvy clients, and big tech engineering companies. They are leveraging some of these tools to kind of make it more proactive decision. But most of the general 90% or 80% of the population or the utilities or the communities, they're still very reactive, because I've been talking with a lot of small, mid-sized communities in the last 5 years, and I've been, what I'm seeing is like the technology is not spread equally, and maybe there are a few top 5% of the communities they are using more proactive solutions. So there's still a lot of work to do, and I strongly feel, at least in the AI and the water resources engineering field, it's not going to take any of the engineering jobs. More, I think it will create more jobs to bring these tools to every, communities out there. And then a little bit of short history of AI. This is also something that based on the survey, it seems like everybody's using AI, majority of this group. But I think AI also has a history going back all the way to 1950s, and it hasn't much happened, until 1990. But on like early 2000, you get some learning, statistical ML, deep learning from Google and large of these tech companies. They were taking the lead on this. A lot of research from Berkeley and some Ivy League schools, and I think what really changed was the large language models. The game had changed since ChatGPT released. That definitely kind of changed it. And the fourth one is the agent, which is more recent one, which is 2022, 2026. And there was some agentic, research was going on, but I think the open cloud, he kind of made it as open source, and that kind of opened up the industry so big now that we can leverage for any industry. We can mimic the human knowledge and work, and that's what we will talk about this the rest of the presentation, that how we can use it to our advantage to move forward much more powerful, making every engineer, water source engineer, more smart and more talented, and also creating this equal level playing field that makes this tools make you. When you go to the room, you're gonna equip with all this knowledge and everything that you have this PhD level, expertise on your hand. So what is an agent? This is something that there's different ways to define it. And the way that I am defining it, or maybe if you go and ask any of the LLM tools, it probably kind of spits out these four different properties, like perception. It needs to observe the environment continuously and kind of understand what's happening. And also the reasoning, can it reason why it's happening, and it can leverage multiple because it's a computer software code, and the agent has all this API endpoint on the back end. It can able to do multiple things and evaluate the trade-offs. And what makes it agent is it's an action, right? So think of a large language model, it's your brain, and agent is kind of like your hand. It can do stuff, So the way that you can define an agent is whatever the action that you want it to take, and based on what are the tools that you give. And then the last one is adaptation. And can it learn from the mistakes it makes, or some kind of a learning adaptation? So I feel like these four different properties kind of defines the agent. And also, like, how do you, like, if I don't know anything about software engineering, can I create an agent? I think you can definitely create an agent with the tools that we have. So the AI agent basics is like you have this, this sphere. Um, you have this large language model at the center. So that's going to be Claude or ChatGPT or Gemini, who you pick your LLM model. They all, these heavy, lifters like, even Grok, I don't want to leave them out. So like there's like 4 or 5 people, they investing significantly in this large language model. And it could be, these large language model could be general purpose model. It could be like very specific to the industry, but Claude and ChatGPT is pretty good at this point. I mean, if you guys use any AI agent or any of the thing, you can kind of understand like this is a revolutionary technology, right? The way that this large language models, the investment it goes into is in the last especially in the last couple years, so there's more than trillions of dollars is goes into this, and the market cap of this industry is so big. Whatever we achieved in the last 100 years or last, I did some S&P 500, the stock market in the, that value was created over time, over like 60 years or 50 years. This large language model is created in 2 years. That's how powerful technology this is. So that's the center, and then you build the tools around it. You can have a soul, um, what is like to be a good or great water resource engineer, like the guy who built the London sewer system, like a Jet, what is this guy's had like has a soul, like they believed in a vision that benefits, building the sewer for the entire city of London or Paris, whoever you pick your role, you pick your role model. You can kind of boil it down to the soul, what it likes to be a great water resource engineer. And you can define it in a soul.md, and what are the skills that you wanted to expose? You can expose the entire, water resource books that understood, like 4 years of study in civil engineering. You can kind of provide all the skills that you learned. How do you QA/QC the model? How do you set up the model? What kind of management you should be using, based on what material. So you can kind of think about all those things can be skills and tools you can expose to large language models. And then the knowledge base, maybe exposed to policies, standards, guidelines. Stormwater is, the guidelines is different. It's not a uniform standard in the United States. Every state has their own, every city has their own standard, like a green infrastructure. So, the stormwater controls just varies from, city to city. So you could kind of like think of like, knowledge base, you can expose that to them. Now, before it's kind of painstakingly, you have to go through them, but now, you just, expose that, document to them so the agent can understand those things. And then the external data, which is, you can the fragmented data I talked about that can be, continuously adapted into a single framework, like the USGS sensors, rain gauge data sets. There are a lot of local rain gauges you can expose to API endpoints, and any other, the FEMA database. If you wanted to pull down the effective FEMA floodplain map, you can also create a simple API, and the cloud can easily create an API endpoint to pull down, search and pull down the data. So all these things kind of helps you kind of define an agent, but it has to have some kind of purpose, like you have to tell them what is the purpose of this agent. It cannot be like a really wide purpose agent. So you can kind of narrow it down. I want to create a hydraulic model agent or flood forecasting agent, so it needs to be very specific purpose, and the user types in the request. So the agent has all these tools, and then the soul and knowledge and skills and the external data kind of works together to provide the response back to the user. So I think this is a very powerful kind of understanding, kind of like what is agent, what is LLM, and how you can define all the other sets of information around the agent to create whatever the agent that you wanted to create. It could be a guidelines agent that pulls down based on the location. Hey, I'm in City of Kansas City. What's the stormwater guidelines? It gives you, whatever the bioretention guidelines, what's the specifications. It could be very specific, agent response. So I'll stop right here. Any questions on the chat box? I can't see the chat in the meantime. So before we go further, Tyson, do you see any questions we need to answer? I think this is a good stopping point.
We can keep going. Yeah, we can keep going.
All right. Okay, so once you build an agent, how you can define a loop for especially the use case that we wanted to build. So this is kind of a simple forecasting loop for the water. It could be water, wastewater, stormwater. Let's think about this as a stormwater use case. We can continuously ingest GIS, radar, satellite, your HEC-RAS model, or reports and regulations in the first observed category. And the second is the generate hypothesis, evaluate scenarios, and let's say you wanted to forecast what's going to happen, and you give all this models and everything, and the agent can take the reason. Okay, I'm getting all these things. I wanted to run this model probably every few hours, and able to ingest that data, run the model, and then give you, recommend or whatever the action that you wanted to perform. Like in this case, let's say you wanted to publish a GIS layers, like where it's going to be flooded. You can generate that and put it on a GIS map on a dashboard, or you can send that to some Dropbox location, and you can, put it on QGIS, or you can send it to your client, maybe flooded buildings or roadway flooded buildings. So you can do some actions based on whatever it has done. And the last one is to learn, and then you can close the loop. Okay, if it, if it kind of goes beyond what is predicted in actual, if you do have a sensor, you can compare them, and then you can kind of fine tune that, observe, and then, update the model and kind of repeat this process, and this can be 24/7. So the agent is continuously learning and defining this. It's up to the water resource engineer or who are the builder or who defines this agent. So you have the whole freedom to do this. This is just one use case I'm saying, but you can kind of define it in a way. And most of the tools that, Claude or, ChatGPT, all these things can build HTML, CSS, on the front end side of things. So, and if you're a little bit familiar with Python and some kind of a database backend, you can kind of build this by yourself. You don't need a software engineer to do it. And most of our, company, we have so many water resource engineers we hired, and all of them learned on the fly how to leverage agent. And they are not software engineers, but they're able to move really, really fast, even setting up the ML model and setting up the HTML, CSS, front end, and also creating a lot of APIs, that's the best way to learn. So you just have to get your hands a little bit dirty, and and you just play around with it. I think you're gonna get that aha moment, like, oh, this is very cool. And these are some of the use cases, and we won't talk about all those use cases, but I wanted to talk about like a watershed delineation, stream generation, digital twin, which essentially what that means is just forecasting. That's what it means, like flood forecasting in this case, or flow forecasting, or depth forecasting, using some kind of machine learning model, or it could be a physics-based model like a HECRAS or SWIM. And the report writing documentation, agent can do it really, really fast and better if you have a template and can create figures and all those things. And automated modeling I discussed earlier, and then automated design. I'm not working on anything on the automated design, especially, if you don't have any, let's say, think of like you have a city that under designed, and maybe you just give the agent to kind of upsize wherever you have a bottleneck. You provide the level of service like 5 year or 10 year. It upsizes the pipes, reduces the flooding, and handle that service without any flooding, or maybe widen the channel. So this is something that very extremely interests to me. There are a couple companies already working on this space. And the optimization algorithm to kind of design like the optimal depth and cover. We worked on some kind of use case, and we can talk about that. But it's extremely important that can take you to 30% or even 50% conceptual design before you get to the detailed design. You can get to that point using some of the agentic tools. And then the last one is the compliance and reporting. And this is also, I'm not significantly working on the space other than reporting, but the compliance side, I think, is also the MS4 compliance. If you're on the stormwater, it's extremely important. A lot of communities, they lack resources, doing that, the checklist they have to do with the state department, and they have to report public education, and all those things can be easily automated through agent and generate the report every couple of years and put it on their website. This is called kind of like, this will liberate like so much, efficiency in this space. I just put down only 6 use cases, but there are, your imagination can be wild and extend based on whatever you're working on. You can kind of use the agent to do, what you're supposed to do. So this is one use case. We have created an agent, and the city manager from City of Warrensburg, Missouri, they reached out to us. Hey, hey, I wanted to develop this land. I wanted to know like how the flow lines are, like the stream, central lines are. And the NST plus ICK, that's out there, but it's not exactly the same. So in this case, they have a better DEM. They have a 1 meter DEM. So we can kind of use this to kind of delineate. So this very small use case, we are providing the DEM, and then we're leveraging a lot of white box tools and other tools to kind of generate um, this stream central lines and watershed boundary, and this did it in a couple of minutes, as you can see. This is something that if I'm a city manager, I wanted to quickly do this by myself to understand where the water is flowing through, and can I develop in this area. It's very simple but very powerful use case. They can kind of ask the agent to kind of see, asking the question in natural English language, and then able to, get the answers right away. So this is not only from a city manager perspective, public works director or the planning department can kind of use this. So that's a very simple use case. And I'm going to move on to the next one, which is the HECRAS model generation. This is the one we're going to do it on Thursday. We're going to pick a test site, a project boundary. And so this agent is what it's doing is just you give a project boundary, and it goes and pulls out. It sets up the 2D model, and based on your mesh size, by default it does 10-meter DEM, but you can kind of go up to 1 meter. It takes more time to set up the model. It creates this land, the land. It pulls down the land use. It pulls down the soil. Creates the infiltration layer. It creates the mesh. And this is kind of like if you worked on a BLE studies with the no structures and everything, it gives you that base model. And we will work on this, on Thursday. And gives you immediately, the HECRAS model that you can actually open it in HECRAS and then actually run it without any errors, So, the agent can also run HECRAS model, but the HECRAS model takes some time to run, depending on how big is your thing is, and you could kind of post this raster back to the platform. So this is the use case. We will probably run it, and we do have some example boundary data sets, and we can able to and walk through step by step how the agent is doing it. And then you can kind of mimic the same thing outside of our platform. And also, we have the same CP server. You can, if you're using Cursor or some other tools, you can also connect to our platform without coming into our platform and do this. But we won't do that on Thursday. But if you're interested in like how to, hey, I have a Cursor, I have a Claude tools, how do I connect to your platform and leveraging this HECRAS simulations, or how to set up a HECRAS model, please talk to me or reach out to me on LinkedIn. We can talk further. But this is a use case, something very useful. A lot of our clients are using it. A lot of engineering consulting companies are using this to kind of set up a quick BLE model. And we also internally, our team uses to run a large scale, flood models for some of our clients. The third one is the hydraulic model results visualization. This is SWIM, and I'm not sure how you guys use some 1D, but now HECRAS can't do 1D, 2D. So we have to do like 1D, 2D. We have to choose SWIM, but now we have option to do completely HECRAS. We are very excited about that. We will implement that also in the agent. But right now we're the 1D stormwater model that we are doing that. To understand the node level of service in this. You can visualize this in the platform also. This is another use case. And looking at the time, it's already 10:45. So I'm gonna move a little bit faster so that we can get to Q&A. And this is another last use case, which is the live modeling. And NVIDIA actually were working on this. They had this physics Nemo model. We used one of our clients and trained the ML model. We ran 500 simulations using HECRAS, and then we trained that model using the NVIDIA Physics Nemo. We optimized it for this location. we have a GPU infrastructure to train. So if you wanted like a big B100 or B200 or H100, we can rent the machine. We can actually set up the models, and we have an AI studio kind of track all these experiments to kind of see how the model is performing and how confident you are with the AI model that you are actually going to use this model for inference in predicting the real-time flood forecasting. And this is a real client in Kansas City. We are building this. The model is already built. The dashboard is already set up. And if anybody interested, I can show you how this, works in real time. And very powerful. We can kind of see all the things, kind of a very transparent AI. So the clients also understand how the AI training is done and model. They own the whole modeling, the pipeline and the model, so they understand how good or bad the model is in, forecasting, severe events. So this is live, and our clients are actually trying to use this in this summer. And I will stop right here. So if you're planning to attend Thursday meeting, please, um, um, register this account. It's free. All you need is an email. And I wanted to make sure that if you're attending Thursday, please register. And if you have any issues, you will have I believe you have like a $5 credit on the AI thing. So we will use that credit to, set up a HEC-RAS model, real HEC-RAS model, and then we can walk through, and then we can also talk about the limitations and stuff. So feel free to register here. I will also put down this link really quickly in the chat. So yeah, and then you need to verify your email, and then once you're in, you're in. And if you have any issues, please reach out to me. It's free to register. You get $5 credit, and then we will walk through some use cases on Thursday. So I'm going back to the slides so that we can get through this really quickly. And you can kind of see like most of these agents are going to reduce the hydraulic modeling effort to build, the calibration time. There's a calibration application, which we haven't talked about. The flood warning capability, you can, do 18-hour, at least 30%, decrease in emergency response costs. These are real numbers. More, scenarios analyzed per, planning cycles. So like I said, it's very powerful. It's going to make a lot of our work very efficient. It's always, this is also something I want to really quickly touch on, which is trust and governance and human in the loop. So you are still in charge, and this is extremely important as an engineer. It's not like you just spin this out and you forget and, fire and forget. You need to have some kind of governance. You need to have some kind of audit and accountability and continuous evaluations. This is what I feel like being a water resource engineer is responsibly going to shift in the coming years, that you need to know all these tools so that you can actually educate your clients in a way that, okay, you don't want to blindly trust this. There's a governance here. If the agent can or the LLM can hallucinate and give you some wrong recommendations. So this is still, instead of human in the loop, you are engineer in the loop, So this is extremely important. This is the area that probably most of the engineering work will be done in the next coming years. And this is some guardrails. You need to have some explicit bounds, tier autonomy, who has the access to pull the plug. There's the kill switches, and also there's a peer review, so someone has to review, like if you're building this, someone reviewing your work, making sure that that's not, if people are start making decisions based on this, you want to make sure that, something is continually monitored. So the last one is not just observed, it's actively managed. That's what the water resource engineering, and also we help this system, it will become like a more dynamic system that we are planning level studies, and we're going to be continuously learning and updating our models as we predict what's happening in the real world. And that's my last slide. I know we have 10 minutes. I know there is a couple announcement, Tyson, you have to make, right? In the meantime, sorry if it took a little bit more time.
Yeah, so we'll leave
Yeah,
8 minutes for questions here. In the last 2 minutes, we'll do some announcements.
sure.
All right, do you want me to give you some questions that I'm seeing in the chat?
Yeah, sure.
All right, so there's one that's come up a few times. It has to do with calibration. So the question says, how is the validity and applicability of the underlying data reviewed before you create a base model?
Say that again one more time.
So, oh, I think I might have just moved it out of the way. So
This is the one that the Brian Brown asked. This is the base model without anyone looking into the validity and applicability of the underlying
yes.
data that it's using. Yeah, so I don't think anybody is going to give you the base model without looking at the um, you have to define what data. So for the use cases, you have to give first something to train on. So and you have to validate the model. So the base model is like it just if you're creating a fresh base model, you will it will generate a base model like a head crash model or some hydraulic model, and that you can validate yourself. If you're setting up a machine learning model, in machine learning application, you have to have a training data sets and validation data sets. So before you actually use this model for prediction side of things, you have to validate that model. So there's always a validity. The base model is something that you have to validate at this point, or you can create an agent to do it if you have a good, the protocols. What are the things you would check? What the current number range is, for this use cases? What's the continuity, errors on HECRAS. So all those things you can set up in the agent. But yeah, at this time, the agent can do exactly what you ask them to do. I hope that answered the question. So
Let's move on to the next question about cost. So using continuous agentic applications can get expensive. What guidance do you have regarding best practices for keeping the costs down? Have you
yeah,
experimented
so
with open weight models?
yeah, so depending on the context, you can use multiple different models. You don't need a very expensive model like a Fable or even like a cloud like a the 4.6 one. So you can use a lot of small ones, like open source models. You can keep the cost down. That's how we do it, on our back end. So we are not using one single, LLM. We are using multiple LLM, and the open source models are really cheap. You can run like millions of tokens, like less than $1 or something like that. So you keep the down, like you want to keep all the simple questions and everything using the open source model, but the heavy lifting ones, like you want to build the ML model for your watershed or like optimizing your weights or whatever, then you need a very big model or you need to spend money on that one. But I think keeping the cost down is the open source models for now. Yeah.
All right, next question. Something that's on the top of my mind that I deal with. So it says, given the continuous evaluation box for the engineer in the loop, how do we handle the speed at which AI output is generated compared to the speed at which a human engineer can review that output?
Yeah, the human is always going to be a bandwidth limited. So that's probably at this point, and that's a great question. So if AI can all this, but it all comes to you, so you're going to be reviewing it. That's what bottleneck by it at this point. So you can run multiple scenarios, thousands of simulations, and it can pick the best calibration fit. It can provide that model to you. And instead of you running like 1,000 simulation manually, the AI is actually running 1,000 simulations, picking up whatever the variable you set. But you still, at the end of the day, you have to review it, making sure that whatever the variable it's picked, do you agree with them? You know, and that's the limitations at this point. And unfortunately, that's the way it's supposed. That's the way I believe it's going to be in the next couple of years, at least. And unless there's some kind of a consensus, that's what I strongly believe the water resource engineering job is going to be get elevated more into this, evaluating this model and how to kind of um, improving the bottleneck at the tail end, right? So you can maybe come to some consensus. So I hope I hope that makes sense, but I think that's what it's going to be. That's going to be limited by a good engineer, but now you can lift a 10x, but you're still limited by that factor. Yeah.
Okay, so the next question has to do with the stream delineation tool. Says, is the agent utilizing a GIS tool or API in the background?
Yeah, so it is using a GIS tool, white box tools in my thing. So we have all the GIS, processing tools, and the agent has access to those, libraries and all those things. So it spins out a small compute, and then it runs that calculations there, and then it will spits out the results. Yeah.
Okay, and then there's a few questions on sustainability. So the one I'm going to focus on says, I'm going to try to shorten it, but it's how do we ensure that AI agents don't inadvertently widen the gap between those who have the structural agency to act on this data and those who are restricted by systematic and historical realities. So it says, especially given the raw materials, massive electrical resources needed for data centers.
Well, that's a heavy question. Can you repeat that?
Yeah, so there's two in it, kind of more on the sustainable side
Yeah.
of things. That how does AI stack up in terms of energy use, and material inputs, and then how is that fair basically for communities? And I know you help a lot of smaller towns, and your
Yeah.
mission is very much towards and geared to helping the smaller. So I think the
Yeah.
main
Yeah.
question is how do you ensure AI agents don't inadvertently widen that gap?
Yeah, that's a great question. That's a philosophical question too. I know the one thing that we are doing is all the GPU that we trained on is sustainable, certifications on the back end. So you can run the compute on anywhere you want, right? So most of the machine learning model that train, they're all sustainable data centers out there. They use water responsibly. And also they have energy mix of sustainable sources, right? So they keep the energy and water. So that's something that we wanted to focus more and more using that kind of data centers to run these calculations. So we are sustainable in that way. And as far as the cost goes, that also comes down to open source model versus the paid model. So if you have a right mix of, most of the use cases, what we are doing, like, running a simulation over and over, or simple questions like what's the Manningson I should be using for this pipe? Those all the things can be run without, tagging into the big, model. These can be like making sure that it's using a very less resource. But that metric is constantly going to evolve. We don't track that information at this time. I know we use more sustainable GPU clusters on that side, and then also, logically we wanted to eliminate because otherwise we can't provide the service to our clients. So we wanted to keep the AI costs low. We are using a lot of open source models. So those are the two things we are taking a friend, but to kind of exactly know like how that's widening or shrinking, and unless we track that information, currently we're not tracking, unfortunately. So, but maybe we should track that. But from a startup perspective, we are mindful of that. And that's why we are choosing who we wanted to work with from a data center perspective. Yeah.
Thank you. We're going to end our questions there. I'll give a minute to Yanan. I'm going to invite you guys to post those questions on that LinkedIn group or Flood Zone, and along if you want, you can continue to answer those or answer them now. And I'm going to turn the time over to Yanan here.
Sure.
Thanks, Tyson and Ilango, for this very insightful section of today's presentation. I'm going to be very quick, and I do see there's a lot of good questions showing up in the Q&A, and that's exactly why we want to set up this venue for everyone from this community, continue the discussion and continue explore this new technology and how to see how as us as a water engineer, how can we adapt to this change moment. So I just want to do a very quick announcement. This subcommittee was established back in 2024, and we were hosted under the ASFPM Higher Education Committee. And this year, 2 months ago, basically in the annual conference which being hosted in Milwaukee, this subcommittee has been officially elevated to a full committee. And this is the first time that ASFPM has ever established a new committee in the past 12 years. So I think this is a very big moment for all of us in this flood plan management community who are interested in this new technology and wanted to see how things going to move in the future. I do appreciate all of your time and expertise and passion contributed to this important topic. So we're currently working with ASFPM staff developing our individual website. So when that's being released, we definitely gonna let everyone know. So for any future questions or suggestions, or if you wanted to get more involved with our committee, please feel free to reaching out to us. I think if we still have a little bit time, basically anyone on today's call, feel free to reaching out. And also I think Tyson shared our page of flood zone on the ASFPM portal and also our LinkedIn page. So feel free to join any of the channel you feel comfortable with and get in touch with us if you've got any comments and questions. That's it. Thanks, everyone.
Okay, thank you all. We'll see you again on Thursday. Have a good rest of your day.
Thank you.